All right, here we go. We're on lesson 3 already. Here we're going to talk more about probability. Yesterday's or the last lesson's probability was real basic in that we were just looking at how many failures, how many successes do we have. But there's more to it than that. Sometimes you have to look at, are they independent or dependent events? If they're independent events, we know that the result of one does not affect the result of the next one, so those probabilities are independent as well. So I can find each probability by itself. If they're dependent, that means whatever comes second is affected by what happened first. Well, that means we have to deal with that probability a little bit differently. So let's see what we got here. Here I have, up here, I have a dime is to be flipped and a die tossed. And I want you to find the probability of a heads and a 3, or a probability of a tails and an even, or the probabilities of either and a prime number. Now, one of the things we can do is we can turn this into a table, or a tree, I should say. Oh, didn't get the one I wanted. I wanted this. There we go. Okay, so I would start with my heads and my tails, and after I had the heads and tails, oops, I don't want that yet. Get out of here. I would then have to, divide up and get all the values. I'd have them all listed out there, and now I can take a look here real easily, and I can see what all the possible outcomes. This is one way to do independent and dependent events. If I do it this way, all I have to do is look at the table and see what it has. What's the probability of an H3? Well, H3, there's only one of them, and there's how many total? There's 12. So it's a 1 out of 12 chance that I would get a heads and a 3. What about a tails and an even? Well, I look down here, I had 3 evens, and with the tails, so that gives me 3 out of the 12, or a 1/4 probability. Okay, what if I get either a heads or a tail? Doesn't matter, as long as I get a prime number. Well, now I got to figure out what are the prime numbers. Well, the prime numbers are any number that only has exactly 2 factors, 1 and itself. So 1's not prime, but 2 is, 3 is, 5 is, 2 is, 3 is, 5 is. I have 6 of the 12 outcomes. I get a 1/2. Okay, so now how could I have done this differently? Well, the first question is, are these independent or dependent events? And the answer is they are independent events, because the dime's result does not affect what you roll on the die. So that if I have 2 events, A and B, and they're independent, then what's the probability of both events occurring? It's the probability of A and B. So notice here we have the word A, and that's one of those things we had to look at in this standard. So now that I have that, notice it says all we have to do is find the probability of A and the probability of B and multiply them. Well, in this case, the probability of a heads is a 1/2, and the probability of rolling a 3 on a dice is 1 out of the 6, so I get a 1 out of 12 when I multiply. Okay, same way, tails, it's a 1/2, and an even number is 3 out of the 6, so it gives me a 3 out of the 12, which gives me a 1/4. So I could do it that way. Now notice I'm doing these with real simple probabilities, in that all I had to do was find one event. I only had to do one of these items, so I really didn't have to do the whole combination thing. That happens when I have multiple groups of things and I'm pulling out more than this one item out of them. Okay, so now what if these would have been dependent events? How do I find that? Well, if 2 events, A and B, are dependent, then the probability of both events occurring is P of A and B. It's still A and B. So the big question is, are they independent or dependent? Notice the formulas start off the exact same way, that we're using probability of A and the probability of B. But notice the change in when it's dependent, it's the probability of B following A. So after A's been dealt with, what do you have to do? Well, let's see what we have here for some possible problems. Anytime I get a problem set like this, the first thing I always like to do is figure out, okay, do I have independent or dependent events? Okay, so a die is rolled 3 times. Is that independent or dependent events? Well, if I roll first one, second time, all I got to do is keep track of what pops up. So these are independent events. So that means all I have to do is find the probability of whatever they want me to do. What's the probability of 3 4s? Well, 1 4 is 1 out of 6, and another 4 is 1 out of 6, and the third is 1 out of 6, so I get 1 out of 216 ways of doing that. Okay? What's the probability of a 2, and then a 3, and then a 1? Well, a 2 is a 1 out of 6, and then a 3 is there's 1 out of 6, and a 1 is 1 out of 6. So again, I have a 1 out of 216 chance of doing this. I could have written the entire list out and see what happens. Okay, 4. What's the probability of three different even numbers? Well, the probability of the first even number is 3 out of the 6. Okay, now, in a way, this is a combination of an independent-dependent type thing. Because now that I've already rolled n even number, I have an influence on what's coming up next. I'm still rolling the same dice. I still have 6 outcomes, but I no longer have all 3 even numbers to choose from. I only have 2 even numbers to choose from. Now when I go to the third dice, I get a 1 out of 6. So this is where that dependent part comes into play, is what's happening. In this case, it was dependent. Okay, so I had a 3 out of 6, a 2 out of 6, and a 1 out of 6. That gets me a 6 out of 216, which is a 1 out of 36 possibility. Okay, so number 6 is, I have an even number, then an odd number, then a 1. Well, an even number would be 3 out of 6, and an odd number would be 3 out of 6, and a 1 would be 1 out of 6. That gets me a 9 out of 216. Which reduces down to, should be able to do that in my head, right? One out of 24. Should have been able to do that in my head. Okay, again, this is independent. Now the second one was dependent because we had to have different numbers. Okay, so now let's look here. Let's try with another set of problems here. There are 3 nickels, 2 dimes, 5 quarters, and a purse. 3 coins are selected in succession at random. Find the probability. Okay, what's the probability of getting a nickel, then a dime, then a quarter, if no replacement occurs? No replacement occurs. So that means this is dependent. That's important to remember. Okay, so a nickel. Well, we have 3 nickels. Out of the whole, how many we have? 10 coins. Okay, multiply that by, then a dime. Well, we have 2 dimes, but now remember, we didn't put the nickel back. So there only left 9 coins in there. And then a quarter, well, we have 5 quarters. We haven't taken any of those out of 8. So we get 3 times 2 times 5, it gives me a 30. And 10 times 9 is 720. So 30 out of 720 is a 1 out of 24 probability. Or about a 4% chance. Okay, so now what if I did the same thing, a nickel, a dime, and then a quarter? If replacement does occur, well, that changes this because now these aren't 10, 9, and 8. I always go back to 10 because I put the coin back in. So now I have 30 over 1,000. Which gets me about 3%, 3 out of 100. So if I don't replace it, I actually get better chance of getting my outcome. Okay, so what's the probability of 3 dimes if replacement occurs? Well, okay, that's going to work out pretty easy. It's going to be a 3 out of 10 and a 3 out of 10. Sorry, not 3. 2 out of 10 and a 2 out of 10 and a 2 out of 10. That gets me an 8 out of 1,000. Not too bad. Okay. Probability of 3 dimes if no replacement occurs. Okay, so on the first one I have a 2 out of 10 of making it a dime, and then I have a 1 out of 9, and then I have a 0 out of 8. There's no 3 dimes. There's no way I could get that. I would have a probability of 0. Okay, last type of problem we're going to look at here today. Okay, so the Divas are planning a 3-day vacation to the mountains. A long-range forecast reports that the probability of rain each day is about 10%. Assuming that the daily probabilities of rain are independent, what's the probability that there is no rain on the first 2 days and there is rain on the 3rd day? Okay, so how do we figure out this part right here? The probability that there is no rain. Well, if it's a 10% chance of rain, that means there's a 90% chance no rain. That goes back to our success and failures. If there's a 10% chance that it will happen, there has to be a 90% chance that it won't happen. So I've got a 90% chance and times a 90% chance times the 10% chance that it will happen. So if I multiply out these percents, what do I get? It might be easier to see these as fractions. I get 81 out of 1,000. And if I write 81 out of 1,000 as a percent, I get about an 8.1% chance that this is going to happen, that the first 2 days are going to not rain and the third one's going to rain. Okay, so that's probability of independent and dependent events. As long as they're strictly independent or dependent events, we're good to go. And that usually happens when you look at something, look at the wording that we have here of 3 dimes, of a nickel, then a dime, then a quarter. We see that we're independently looking at things. As we go on in this unit, we'll find out what happens when we start getting into events that aren't independent or dependent. You ready for this lesson?